of what you learned in chapter 5 and recall F equal to ma in your solution. In chapter 6, you will be focusing on central or mass. You will start to see CG point in the question. When you see, it will give you one CG point, then that one is chapter 6 question. Okay, and then you recall what is the moment around the gravitational point, then you solve. Okay. This is a short video on what is flywheels. It's rarely seen nowadays already, but it's good to introduce you guys lah. So what is flywheels on the tractor in 90s, I think 50 or 60s, there are lots of this kind of tractor. Okay, 1926. So they crank the engine. This is the flywheel. Okay. Okay. So we start to look at how we apply equation of motion to our rigid body. So again, this chapter we start to look at central of mass. Central of sorry, not central of gravity. Just now I mentioned center of gravity. Central of mass. So we start our introduction in the mass moment of inertia, dm, at 1 moving in the circular motion r. Chapter 6 onward, you need to recall how to use the diagram to find the ixx, iyy. But in the exam, you'll be given that diagram. Okay. All right. So you've seen this one before in your static class. Second moment of inertia equal to integrate of your r squared dm. So what is r? R is the radius from the axis. Okay. All right. So this one you're familiar. And if we are referring to center of mass G here, the common unit for moment inertia is kilogram meter square. Kilogram meter square. Because when you integrate your mass, you get kilogram. R square, you get meter square. This is a recap, is what you learned in your statics. So how do you calculate from density? If you want to calculate your mass, you need volume. You need volume. You take volume, multiply by density, you get mass. Okay. So in chapter 6, sometimes you need to calculate the volume, and then you multiply with the density. Okay. So you start to change your moment of inertia integration equation from r square dm into r square rho dv. Rho is a constant, so you pull your rho outside. Okay. So you integrate r square dv. If you pull your rho outside, your integration will be v dv. So if you look at this equation, we change from integrate r square dm into rho integrate r square dv. You can calculate your velocity if you're given a certain dimension. R is the distance from your reference axis to that particular point, right? So there are three forms of equation you can use in chapter 6 question. Moment inertia, you integrate r square rho dv or rho r dv. First shape that you see is a cone shape, right? So how to find? This one homework. How to find volume? You integrate x, integrate y, integrate z. This is a triple integration to find the volume, right? So I think you all expert already in integration, so I don't need to go here. So you link what is V to this triple integration with x, y, and z. So for shell element, with thickness, dy is chosen for integration. So here, if you want to integrate this shell element, okay, we use this formula. How you calculate volume of this small dv? You take the circular radius, the circumference, pi r square, or in this case, you change your r into y. So 2 pi y, z, and dy, you get the volume in these small changes of volume, right? Okay. Then you put inside there. But anyway, all this derivation, you won't be asked in the final exam or test 2. There's a table for you to refer. So your job is to how to apply the table. Okay. For this element, just now is cylindrical. This just now is this cylinder. You choose the thickness. Now, what about the Z? The Z, same. How you find the volume of this dV equal to, you take the area. Area is pi r square. Now your r is y. So pi y square dz, you get your volume. You are referring to z if you use dy square dz. Okay. Now previous slides here, dv to 2 pi yz dy, this equation you're referring to y. This equation you're referring to y-axis. This slides you're referring to z-axis. So when in chapter 6, you need to be careful on the axis that you use. So you don't sum everything in one axis. You break them into y-axis, x-axis, and z-axis. Okay. Okay, the rest you read from the slides. Let's try to determine, this is just a recap you learned in your statics. Determine the moment of inertia of cylinder below about z-axis. You are looking at z-axis. So z-axis, you're actually concerning this plane. Okay, now the density R, density material here we use R or rho, is constant. So here we solve by using shell element because referring to z-axis. So, shell element here is okay, the z-axis. So this is y, referring to y. So volume is two method. This is a shell volume. dV is 2 pi r h dr. You get the volume. How to get mass? You take rho dV. I think the question, the r here need to change to rho. So you substitute the dV in a shell element calculation. You arrive at this equation. Then recall your second moment of inertia equation. Integration of your r squared dm. You pull this equation into dm area. You reach this one. So I in z axis will be integrate of your r square rho 2 pi r h dr. We are focusing on r, so all the constant you pull out. Rho pull out, 2 pi pull out. H also fixed. Well, you're focusing on R. So you reach this equation. Second moment of inertia in z-axis equal to rho 2 pi h integrate 0 to r, 0 to r cube dr. How to get cube r here? R square here, so you have r cube dr. You integrate cube, you get r power 4 divided by 4. Right. So you get this equation. If you want to derive the second moment of inertia about z-axis, you get this equation. Okay. So anyway, this equation you are seeing in the table when it comes to assessment. Only you need to be careful on the axis that you're referring to. In this case, in this example, you're referring to z-axis. Some example you need to referring to y-axis, and some example you need to referring to x-axis. Okay. So the rest you read from the slide. This is just to put in terms of. So you just derive according to mass. Okay. This one I go very fast. You look at the equation, m equal to integration of dm. So you pull this equation, you pull dm, you put inside here, you pull all the constant value out, then you dr. This one, when you integrate r, you get r squared divided by 2, you get, then you remove the 2 in front, you arrive at this equation. So your m equal to this one, and your Iz just now, your Iz you derive is rho pi h r power 4 divided by 2. You get your m equal to this term, rho pi h r square equal to m. So this one simplified in the mass term. You get I second moment about z equal to half mr square. You see this equation in the chart, in the standard chart that you see in the final exam. Okay. So this is along the axis. So this is another example where you have x and y, but different shape. This one, density material given, determine moment inertia of solid in y-axis. You are given the shape equation, y square equal to x. Okay. So you use this element here. You make a small this element like this. So you have a delta y and you have a xy coordinate there. So you calculate based on mass. How you calculate mass for this small this here? Is dm equal to rho dv. Rho is given. How you calculate v? For this element, pi r square times the thickness, right? How you get the mass, volume of this? Pi r square, the area, times the thickness, you get volume. So pi r, your r now is x. So you substitute your r with x, pi r square, pi x square, dy your thickness, right? So you can still using x the axis, but we're not going there. We stay at y-axis, right? So example 1, if z-axis is mr square, so if you want to find the second moment of inertia, you take 1/2 dm x square. Okay, just now is a z, now you're referring to this axis. You just change the term inside. Iy equal to 1/2 m become dm x square. R is your x now. So you substitute all these things inside here. Again, you rearrange. Substitute here, you rearrange. You substitute x equal to y square. So x equal to y square, you want to put in terms of y. So you change everything in terms of y. So x How you change x? Because the equation here, right? Okay, wait, wait. X square. Yeah, correct. X square. Okay, either this one wrong or the diagram wrong. Huh? Let me try. Substitute x equal to y square. It should be y square equal to x. Huh? Let me watch the next steps. Okay, we continue with the calculation. Pi you move out, rho you move out, x square here, x power 4 dy. You have limit 0 to 1 meter. So you get, at the end, you get x power 4. You substitute x equal to y square, you get y power 8. Huh? So I think there is a typo error in my slides here. It should not be x equal to y square. It should be follow diagram, x equal to y square. There's a typo error in my slides. All right, you follow the diagram. You do the calculation, you get second moment inertia equal to 5 something kilogram meter square. Okay, so this one, anyway, you'll see this one in the table anyway. So I'll go very fast here. Huh? So we introduce you parallel axis theorem now. Look at the diagram. You have fixed axis z and moving axis with the prime. So this body is moving, and you have your x prime, y prime, and z prime, and you focus on the mass on the rigid body, dm here, and the center of gravity, center of mass is over here, g. So again, when you see question with the symbol g and the dot there, it means center of mass. Your calculation will be focusing on that point. Then the rest is, you can read from the slide here. The rest you read. The rest you read. Okay, I want to show you equation. The rest you read. So we try to derive equation for parallel axis theorem. If you use this diagram and you use Pythagorean theorem, your r square equal to d plus x square. This one, this rectangular, triangular. So how to find r? Square this one equal to this one square plus this one square, right? So d plus x square plus y prime square. And recall the second moment just now, I equal to integrate r square dm. We are focusing on z-axis. So you substitute your r in here, where you derive from Pythagoras theorem. You integrate the r square in x and d and y prime. And you have two terms there. Huh? So you pull, you do the calculation. This one is the quadratic equation. Then you group them together. You rewrite, you get these two terms. Right? So x prime square plus y prime square, and then the x prime. One more. Huh? Okay. This is mathematics, but you don't need to memorize this one. Right? So you're actually using Pythagoras theorem and the earlier definition of second moment of inertia. You arrive at one equation. You arrive at this long equation where the first part is represent second moment equation at point G. The second one, you can cancel because at x prime here, when you integrate with the small changes of x here, you can get 0, right? So this is when you integrate lah, when z-axis, this one. And then the last one is the total mass of the body. So you will arrive at one equation, but it's important for your incoming assessment. This one, you always need to memorize for chapter 6. The first step, you solve question 6, you write this equation. I equal to Ig plus md squared, where you are considering initial at G, second moment at G, and total mass of the body. You look at 2 dimensions. One is what happened to the G, what happened to the mass. So you arrive at this equation, I equal to Ig plus md squared. What is D? D is from the reference plane to the center of gravity. Okay, you always have one reference plane in the question. So D to the G point, you calculate the D, and then Ig, this one, you refer to the chart, standard table chart. Okay, here, this G, you need to be careful on the axis that you're referring to. Okay. So for composite body means you have a loss of body where you'll see in your final exam. Composite body means you have round body plus a rod. Then you need to you have 2 sets of equation. One set Ig plus md for the sphere, Ig plus md square for the rod if you have composite. You need to do 2 sets for each individual body, and each one is from the reference point. For example, the round body and the rod. So your reference point is from here to this body, and this point to the rod, and so on. So I will show you in the example. And also this one, you'll see this one in your test 2 and also in your final exam. Okay, you will see this chart here. Okay, so example, if you have, for example, a cylinder body, just now, right? You have IXX, very small, but you can download from the canvas actually. So IZZ and so on. So you're referring to each of the axes, you refer to the equation. If you're referring to X and Y axis, if you're referring to here and here, then you use the first one. If you're referring to Z axis, then you refer to the back one. So quite direct, yeah. So or example here, rock. So this one and this one is quite popular shape. This one also popular shape that I will use. I'm still considering whether I want to use this one or not. Okay. So for example, this one, the rod one, you have X and X prime, Y and Y prime, and Z prime. So you're referring to each of the equation. Okay. Actually, chapter 6 is quite an easy question because you're given this table. And then there's only one equation, one or two equation to memorize. The first one is I show you, I equal to Ig plus md squared. Then the rest you're referring to this one. Your Ig referring to this type. Okay. Okay, let's look at example 3. So you have this object, we have all the dimension, and you see G in the question means you're in the chapter 6 question already. Thickness is given, O is given, so have a density given means you see density means you need to calculate mass. You need to calculate mass means you need to calculate volume, right? So thickness is given, calculate moment inertia about n axis. In this case, it don't give you any axis, but you just assume that is at G. So you break this part into 2 pieces. If you are good in 3D modeling software, SolidWorks, AutoCAD, or something, how you get this shape? You take a big piece and you subtract the small piece. you delete or you punch a hole in the center. So you get this one minus a small one. So how you calculate the moment inertia? You do one set this one, then you do one set for the small one, big one minus small one. You get the answer. So table, in the table just now I show you, I enlarge it. This shape is inside here, this one. I extract this one from the table, and you'll see the same table also in your test 2 and final exam. You'll see the same chart also. So you refer to this chart here. So you look at the shape and orientation of the shape. So here you have a lot of axes, right? You have x axis, y axis, z axis, and z prime axis. So which one to use? You use z axis because you look at the same orientation. Okay? It's depending on where you look at the. In this case, you look from the top, it is zigzag direction. So zigzag direction, straight away from the table, you know that you are using this one. In your answer sheet, you write I zigzag equal half mr square, you get 2 points. Okay, 2 points or sometimes 1 point. It depends on the length of the calculation. You copy this one, you get 3 marks already. Second equation, as I mentioned, you write this equation, you get another point. I equal to Ig plus md squared. That one, every time you see a G inside the question, you write this equation. This one you refer to table or chart, right? So Ig from the chart, half mr square, md square you copy. This one is for one body only. You have two body, you need to do 2 sets. Okay, how to calculate m for big body? You have the density, you have the radius, you have the thickness. You're able to find the mass for the first one, and this one also same, right? So I do the first one for you. So for the big disk, I write half mr square. How to find m? Rho times volume. How to find m again? Same, same. So you just substitute, you get 1 point something kilogram meter square. Right? Start to be familiar with the chapter 6 unit. For second moment inertia is kilogram m square. Okay. For the whole still same. You substitute the value, you get the answer. But don't stop here. It tell you this object have a hole. You take the first one minus the second one. Okay. You get 1.2 lah. Although here I put a plus there, when you do calculation, it should be minus. Okay, although on the slide here I put positive, but it depends on the case you have. Then you do calculation. Okay, then we take what we learned in chapter 3, in example 3, we look at more complex one. Actually, the same concept. Right? Don't be fooled by the question. Actually, very easy. So far, only see 2 equations. I equal to Ig plus md squared. And then the other one you refer to table. Okay, here you see a pendulum here. Pendulum, you look at the diagram, what shape you see? You see a rod and the rod. Right? You see rod and rod. So you go to the table, you only look at the rod. You don't look at other shape. You look at rod body. Then the rest you look at what as the reference. So you have a pin O consists of 2 thin rod. It give you rod already. So you go to the table, the chart just now, refer to rod, and then copy the rod equation out. Rod OA had a mass, given the mass even, of course in exam you won't given the mass lah. We'll give you the rho. You need to calculate the volume. So in this tutorial, give you the 12 kilogram. BC also give you the mass. Determine the moment inertia of the pendulum about an axis passing through. There are 3 cases here. 2 cases. One is past point O here. Second set of the answer will be past central mass G of the pendulum, which is here. Okay. First, you write the standard equation for chapter 6. I equal to Ig plus md square. You look at the first object. First object is rod using table. So you go to the table, you look at the rod. So you compare side by side where you're looking for, how you see this shape from this diagram, right? So you're seeing shape from okay. Here you're looking at x prime and y prime direction. Because why? The first set is point O. We ask you point O, not point G. This is G. If you're looking at G, then you refer x, x, and y, y. I repeat, you looking at where you focus on. The first part is, say, O, is at the end of the rod. So you look at the table, you go to find where is the end of the point here. From the table, this is the end of the point. So you refer to s prime and y prime. So you go to the below the diagram, you go and refer to x prime, y prime, y prime. Copy this equation. If you're referring to end point. For part B later, referring to G, you're referring to G, go to the table, where is your G? Here. Where does this G touching? X and Y. So you're referring to X, X, Y, Y for second cases. This is how you apply. Very straightforward. Okay, so we'll do the first one. First one, if it's at O, you just copy the equation 1/3 ml squared. Even the dimension was given. Okay. So the first one, you use table, substitute value there. M given. Of course, in test or assessment, you're given density. Then you calculate volume. Okay. L from the diagram 2 meter. Substitute 2 meter here square. Press calculator, you get the answer at O. Repeat the same for B. I should change this one. I should change. It's not part A, part B already. Part B, because you are referring to G, you're referring to diagram. Where's G? G is X and Y. So X, X, Y, Y is the first one equation. Copy this one in your answer. Substitute the value, right? So, okay, so this one is, sorry, still A, still A, because you need to complete the total inertia, second moment inertia. So you copy I equal to Ig plus md square. You already find the value. So wait, IO this is 2.0.016. Okay, I think the second part, this one, the second part, this slide is referring to G position. This one, this set of calculation is referring to G. So G, when you're referring to table, is IXXYY. You copy from the table is 1/12 ml square. And then you substitute into I equal to Ig plus md square. You'll get this one. Okay. Your D is 1 meter. Why? Your D is 1 meter is from O. O to G. O to G is, G here is what? You see Y prime? Y dash is average. Y prime is average. So here to here is 2, average is 1. So you substitute D is 1 here. For L to G is 1 also. You substitute, you get 16. Yeah. So what about BC? BC, same. BC, if you look at BC, is a rod. and a parallel axis theorem. So your IG, you use the 12 ml square. Then you substitute. Why you use the first one for BC? Why? Because you have a center point. This rod was made at center point here. That's why you use the equation, the first one, because the G is at here. You're looking at the point over here. So you substitute, you get this equation. Again, you're applying I equal to IG md squared. You get BC equal to 37 point something. So from all, you substitute the value you find just now, you get the final one. Okay. Okay. For B, you use the average because this one is y square. Y dash. How you find y dash? This one you learn in your statics. All the mass times the average equal to sum of y average m. So you rewrite the equation, you get this one. You substitute. So how to find the top one? We have two body. You look at the first. Let me see. First body is 12. The y dash for first body is 1. For second body, 9 kilogram. The y here is from here to here. For second body, for BC, the value 2 here because here to here is 2. Okay. So you get 1.4 meter. This for find the y average for this body. Okay. So again, we are applying I equal to IG MDO. So you substitute the IO just now. Inside here, mass, you calculate the total, 12 and 9 get 21. D you find just now from the above equation. You find your IG equal to 10 point something. Okay. So this is how you find for your second moment. Then we start to look at all the force and moment on the rigid body. So on this diagram here, you combine chapter 5, where you see alpha, you see omega. Chapter 6, you are interested in the moment of inertia. So you have reference axis P, G, XY, and all the force. You know that from chapter 1, chapter 2, chapter 3, chapter 4, when you have a force, you will create acceleration, F equal to ma. Okay. So the rest you read. I'll just give you the final equation. So for chapter 6, when you deal with rigid body under forces, and you see there's a G inside the question or in the diagram, you 100% you need to use this equation. F equal to ma, but the A is now referring to gravitational center of mass, and no longer referring to the like what you see in particles. Particle because it's one dot, so there's no, the point is the point. But rigid body you need to find, or it will be given where is the exact location of the center of mass. Okay, so we start to apply F equal to ma G in the calculation, right? Okay, the rest you read. Okay, and force and acceleration, they are vector. So you can break, again, you can break into x direction, y direction. Okay, you're quite familiar with the procedure already. Okay, important is that this is the, I think, the third equation you learned today. F equal to ma, but we focus on center of mass. And you break the vector into x and y. Okay. Rotational motion, you just read. Okay. Chapter 6, you start to combine free body diagram and kinematic diagram, which you need to do in your coming test too. This is what we expect in the question, already very direct. It will tell you section A, construct free body diagram, and sometimes free body diagram, sometimes the kinematic diagram was not mentioned, but it was expected you to draw two diagrams. Yeah. So even though the instruction do not tell you to draw kinematic or kinetic diagram, please draw kinetic diagram in the for your solution. If you see there's a G point in the question, means chapter 6 onwards, please draw these two diagrams. Okay, F equal to MA. F equal to MA, so means on the left hand side, you only look at the diagram, convert what you see, what you understand is a force, you put on the left hand side diagram. And then whatever that give you the acceleration, you draw the acceleration. But focus on the center of mass. Okay, I'll give you an example. So all this you read, all this you read. I will not go deep into that. And then there's a moment there. Okay, so all this you read, I will give you direct example. Because I won't ask you to derive the equation. As you can see, you start to see omega r over there. All this I won't explain. You go and read the slides. Okay. So in your solution, in your solution, you need to consider the moment effect. The moment effect in your solution. I'll give you an example. All this you already know already. All these are mathematics derivation. Okay, I won't go deep into all these mathematics because you won't ask you how to derive this one. Okay. I will arrive at one equation. This one. The moment at that point P, at the end, you use I alpha. After all these long mathematics, this is what we expect from your solution. Moment at point P will equal to Ig alpha. How to find Ig? Again, refer to table. Alpha is what you learned in chapter 5. Alpha is what? This one. Angular acceleration and yeah. Okay. Okay, all this you read. So yeah. So if you have a equation of rotation motion, then be careful to find the average of your x and average of your y. This one is very normal. Okay, I'll give you a lot of example on this. So the rest you read is just all the repeating same equation. Okay, the rest you read. It's all the mathematics equation. Your homework, all this you read. Okay. You need to use the moment of the force and the kinetic motion on the left. What does this equation tell you? On the left, imagine you have two diagram, right? One is the force diagram or free body diagram. This side is a free body diagram. From free body diagram, you can find moment, right? You understand? Okay. Yeah, I'll give you an example. You have two diagram, free body diagram and kinetic diagram. Let's say you have body. this body was subject to force at this point, and there's a distance here. Kinetic, after this force, you're given a G, and this G was moving with acceleration G. So this side is all the moment that you create by the force. So F times D, you get the normal moment. But for this side, the MK, this one is you take the force MA, which is you take the mass times the acceleration of the gravitational point at G. I'll give you an example. All this you read. So yeah, this is on the straight line. If rectilinear translation, what happened to the diagram? On the left is all the force, free body diagram. On the right is happening to the center of mass G and acceleration. Okay, so what is important for chapter 6? You need two diagrams, free body diagram and kinetic diagram. What are the points that you need to focus on for the left-hand side diagram? You include all the force for that body, and then you include, does the force create moment or not? How to create moment? The force must have perpendicular distance from a reference point. In this case, from G. Okay, force from D, you create moment. This one you need to split into X, Y, so perpendicular, or then you'll create moment, and so on. Okay, you sum up all the force, you get this diagram. On the right-hand side diagram, you're focusing on the G point, the gravitational center of mass point, and the acceleration. For example, point A. So point A will give you a momentum where you write F equal to ma. So MAG. And then this MA actually is a force. MA, you combine this, you take M multiplied by acceleration, you get force. When you have force and distance, you get moment also, right? So you take MAG times the D, you get another side of moment. But this side is from the gravitational force, center of mass. Try to split between the two. One here is under force effect. On the right-hand side diagram is on the F equal to ma or mag effect. You're focusing on mag or acceleration at your center of mass point. Time the distance must be 90 degrees to the distance. Then you get mag times d. You get the right-hand side answer. This is chapter 6 additional procedure. Make sense, huh? Okay, I'll give you an example. This three equation is very popular to solve chapter 6 question. First, you sum up all the moment at G. Second, you do F equal to ma equation, A at the G point. A at the G point, huh? Okay. So here very fast. Okay, you always need this equation, huh? Left hand side is all the force to create moment. Right hand side is the ma times the d. You get the moment from the acceleration at the center of mass, the G point. Okay. All these are just calculation. The rest is still same. Rectilinear, you just convert into normal tangent. Okay, same, but you are looking at normal and tangent things. Okay, I'll give you an example. I think more practical is give you same. First equation you look at, total moment equals 0, all the force equal to ma, all the force equal to ma. For example, this boat was pulling by this track. Left-hand side is your free body diagram, right? All the contact point will have normal force, as you know. So point A, front wheel will have NA. Back will have NB. Okay. Okay. Then you have the center of mass. Now in chapter 6, all your weight must go through the G point. Chapter 6 question. Don't shift your W to other position. Not like chapter 1 until chapter 4. Because particle is only one dot, so it's still at that point. But when you talk about rigid body with the mass, then all the mass will go through the center of mass. Okay, then T pull here. This is the left-hand side. Once you do this one, kinematic diagram, how you do? Again, you only focus on center of mass and M times the acceleration of the G point here. Again, MA is a force. MA is a force. Force with the distance, reference distance from point B will give you moment. So moment here equal to moment here. Here, how you eliminate this force? You put your reference point here. You don't need to consider NB anymore. In your calculation, you eliminate NB. Then you only focus on this moment. And for our calculation, anti-clockwise positive. Or you can fix your own clockwise positive. Don't mix. Okay? Fix with one direction and then stay consistent. I will always have anti-clockwise positive. Okay. Okay, now these two diagrams is important. F equal to MA. Free body diagram, only force. And then pay attention to your center of mass. Your weight must go through the center of mass G. Second diagram, kinetic diagram for chapter 6. You are more interested in the point G acceleration. Remember to times the mass, you still get back the force. Because you want to get the moment at the center of mass, you convert mass and acceleration into force, and then there's a distance from one of the reference point B. These two must in sync, must be the same. If on the top you use B, at the bottom you also use B. Don't the first one you use A, then you suddenly the kinetic diagram you refer to at that point must be consistent. Okay. Okay. Right. We go through this example and then we call it a day. You look at the diagram, you know this is chapter 6 question. Okay. You look at the question, you see G point is chapter 6 question. So you are given A and B point with the distance. You are given the mass and determine the acceleration if the rear driving wheels always slipping, where the front wheels are free to rotate. Ignore the mass of the wheel and the coefficient of friction between wheels and road you're given. Draw the free body diagram. Free body diagram is only force. What are the force you have? Before friction force, what force you need? Normal force. So draw your G point first. Your weight always go through G point for chapter 6 answer. You don't put somewhere else. Your W you point somewhere else, I'll give you question marks. Then reference point from the wheel, point 3, normal force, A and B. This is your free body diagram. And then there's a friction force at B because A, it tells you front wheel free to rotate. Free rotate means no friction. Yeah? Free to rotate means no friction. That's why no friction force at A. You have done with your friction diagram. You focus on kinetic diagram, huh? Okay. This system was in not equilibrium, but you know that these are the three equations that you normally will use. You look at the moment. Moment around G will equal 0. So you fix G, you can find moment, right? So this one anticlockwise positive. In your static, you put here, you see how many force. This force, this force, and this force. You have 3 moments there. How to find moment? Fix here. This one rotate clockwise, so negative. This one rotate anti-clockwise, positive. This one rotate clockwise, you get negative. Negative NA, this one. Positive, negative, equals 0. How to find MAGX? Force in X is F. Okay, so okay, this one, I think I didn't put in the kinematic diagram. Kinematic diagram, you focus on acceleration at G, right? Acceleration to front there. So FB, uh, 0.3 meter equal to mg. Wait, sorry, this one should be NB, not FB. It should be NB. It should not FB. Sorry. Typo error. So same. Y also same. NA plus NB minus W equals 0. Why 0? Because there's no acceleration in Y direction. Your car move in front, move to the left. So no Y direction acceleration. These are the area of careless mistakes normally. You will stop here and then thinking, what is the value of my A1? Then you stop here. You cannot do it. Okay, actually 0. So you substitute, you can find all the missing value. Solution 2, this is one that I recommend. And so solution 2, you add in kinematic diagram, you put in the G, and you put in MAG. Again, M times acceleration is the force. Force with the distance, you get moment. Okay, you use this equation. This is free body diagram. This is kinetic diagram. Yeah. So MA, again, you convert all the force at point A. Means I put my reference point at A. Your kinetic also reference A. So A, you have 1, 2, 3, 1, 2, 3. This one do not create moment. Because this one, the D is 0. So you only have 2 moments. Positive, because anticlockwise. W should be negative. W should be okay, NB positive. Okay, this one should be negative. This one should be negative. Typo error. With your X also same. Fx equal to MAG. X still to do the same. You combine, you'll get your AG. All right. Okay, so we stop at example 5. This question come out before. That's for your info. Okay, we stop at example 5. Wait.